All right. Everyone, give it up a big level 10 hooting and hollering welcome to author of SolidJS, Ryan Carniato.
As he said, my name's Ryan. I'm the creator of SolidJS, and today I'm going to present an introduction to it. You're like, wait, isn't this a React conference? I want to challenge our expectations of what the future of web frameworks will look like. And I don't mean purely looks. If you've ever seen Solid, which many of you probably haven't, it looks a lot like React. It has JSX, it has composable primitives, and you might be wondering, like, what am I doing here? And really, it's not worth my time trying to promote it on features. One framework adds a feature, the next framework adds it. It just kind of goes on. I think we're past that being a differentiator. To cut it short, Solid has most of the features of React 18, just to kind of get an idea. Nor am I going to try and sell you on benchmarks and performance. No matter how dominating a display in server and browser, people tend to kind of tune out after a while. Like, it's a meme at this point, like blazingly fast. Like, I'm just going to say good performance and we'll move on. Okay, so I swear this is not a reenactment of a JavaScript framework conversation on Twitter, but I wouldn't blame people sometimes if it feels this way. It wasn't so long ago when the mere mention of a new JavaScript framework brought anger. And it's only been actually really recently that I've noticed that people have been a little bit more open to new ideas than they've been for a long time. There's been this kind of sense, and this is kind of inside and outside of React, like this new paradigm changes happening, right? And it's often accompanied by some faint memory of a time when React burst on the scene, conquering the jQuery hordes and thrusting the web development forward years in one swift stroke. And I don't know, is that really how it happened? History is written by the victors. And my memory of events is actually a little bit different. The time before React was one full of innovation and exploration. Many of the pieces actually kind of already existed, but we hadn't really figured out how to put things together in the right way. We didn't have the right opinions on what we were doing. We just kind of were just playing with it. And I feel like right now, we're kind of back in one of those scenarios again. So yeah, here's my big headline. Modern front-end web for years has been about components. Class components, function components, option components, web components, components. And for good reason. Components are essential building blocks that allow our programs to be modular and composable, and we owe React for this change in mindset. However, in almost every JavaScript framework, components have runtime implications. The update model and the life cycles are tied together. And this has led to basically two views of the world. Either you're going to have like a virtual DOM that diffs, or it's like tag template literals, run top down, or alternately, you're going to rely really heavily on compilation. But in both cases, the components still update top down. And when you're running things top down over and over again, at a certain point, you start thinking about like what needs to run, what matters when it reruns or not. And this sort of begs the question, when or what do we memoize? There's a great talk last year at ReactConf 2021 that addressed this exact topic. So I'm gonna steal a few slides from there here. So your first inkling might be to build a to-do app in a framework like React, kind of like this. Declare some state, event handler, wire it up. But if anything other than the to-do list changes, the to-do list still ends up re-rendering again, right? It's just kind of how it works. And this is okay. We have a virtual DOM. Make sure this isn't very expensive. But we still want to optimize. And as your program grows, you apply some optimizations and things start looking a bit like this. Maybe you add a filter and some props coming in from above, and then you annotate things with memo and use callback and get your dependency arrays, and like everything's working exactly how you want it to now. But it's a bit of a departure, like, okay, from where we started. And it kind of puts the onus on the developer. So what can we do about this? Well, compile it, right? This meme floated around Twitter about a year ago. I definitely felt the lack of dependency array envy from some circles. And I mean, after all, wouldn't it be better just to express our intents with less code? Let's hold that thought for a moment, okay? So back to our to-do list. Now, this is like the most crazy slide from that presentation. And this is the compiled output. No one writes that code. But this was kind of like a pseudocode from what a React compiler would generate. And it actually isn't all that different from what a framework like Svelte actually generates. It's a bunch of shallow checks. There's this memcached object you see floating around. And basically, we can kind of check at every decision point to make sure that we don't do extra work. And the developer just writes nice JavaScript, and it just all works. But there's a common ground here. Basically, a user or an event updates the state. We mark the component as dirty, and then we rerun it. And we check against some memoized values to reduce that work. It doesn't matter if the original code called set state or used an assignment equal sign, like Svelte, React. It's actually amazingly similar from a mechanical standpoint. But I'm here because I want to throw this out here. What if we just didn't do any of this? What if we only ran what was needed to be run and didn't rely that heavily on compilation? What if the boundaries of our components didn't dictate the performance of our web applications? To do that, I kind of need to go all the way back to the beginning. Yeah, so we're all the way back here. Hello, world. It wasn't very long before we kind of realized we could, set a value to a variable and console log it, right? And then you're like, oh, we can set it again and console log it again. And then we're like, okay, this is not very dry, too much work. So let's extract that into a function. So now we have our greeting component, and we're pretty happy. We can change the name. Sorry, not component, function. We can change the name. We can call greet, do it again, and whatnot. But at a certain point, we might be thinking, what if I always want to greet my friend whenever I change the name? And to do that, there's lots of ways of doing it, but my personal favorite ways is something called reactivity. And I want to talk about it because reactivity's been kind of, it was around a long time ago, and then it started kind of spreading itself out again and kind of making a comeback. And basically, I would argue that almost all UI frameworks are reactive in a sense. It's at the heart of it. You want your user interfaces to stay in sync. And the way I think about it is like a system of live equations, like a spreadsheet. See, a normal assignment represents a moment at a time. Like it means at the end of running this equation, A is the sum of B plus C. But if you change B or C, well, you have to do the sum again. But with reactivity, that relationship does hold through time. It means that A will always reflect the sum of B and C. It's a rule. And what I like talking about often is something called fine-grained reactivity. Some of you might have seen this before, like MobX, and things like Vue, and Preact just released some signals last week. And I think it's really interesting because we're seeing a lot of this actually at the framework level because there's a lot of nice properties about this. Declarative, relationships are set once and then executed. You describe the behavior rather than the implementation. And they're composable, they're easy to wrap. You can just, build them up. And the most important thing is there's actually 3 primitives that you can basically build a whole system off of. And I stole this right out of the MobX docs. It's great. Basically, there's like our observable state. I tend to call these signals. There is our derived state, or computed values, and then there's our side effects, which could really be any kind of side effects. Obviously, I've been showing you console logs, but it could be rendering. And with these 3, you can accomplish amazing things. So, React hooks, right? Not exactly. From a language perspective, you can consider this React hooks or something like Svelte, let, and $signs. But both of those are tied to the component, right? You mark the component as dirty. And these composition patterns that I'm talking about have actually existed almost a decade earlier in JavaScript. Like Knockout.js in 2010 had this. Reactivity is a system unto itself and has no connection to rendering or components. And that's really, really important here. But it's probably easier for me just to try and show you this. First thing we need is a new primitive. Setting a simple variable can't cause other code to run. So we need something special, kind of like a promise here in order to do this. So I'm going to introduce to you a signal. And all signal is a getter function and a setter function. Basically, it holds a value. Call it to get the value, set it to update the value. And as you can see now in our greet function, we actually have the call name as a function, but we're also setting friend when we update the name. But this doesn't do much on its own. So I'm going to introduce a second primitive. Let's call it create effect. You start seeing some analogs here between like React hooks, but there's some differences here. And our create effect Basically, we've moved our greet function into it. And now the idea here is whenever our friend name changes, we console log it. It runs initially, so it runs top down, and we console log hello John. But then later, when we call set friend and update to Mary, it runs that effect again and logs it. And the real power is actually, this is transitive. So if I wanted to make the friend name uppercase for some reason, I don't know why, but I decided to make it uppercase. All we have to do is call the upper function inside of create effect. And because it's called underneath it, using the call stack, we actually can still track that signal. If you notice, there's no dependency arrays yet. So like, is this some kind of magic? Am I using a compiler here? No, this is completely runtime. And I mean, at one time, people did really think this is magic, but what I love about this, honestly, is we can probably implement this easier than that interview question where someone asked you how to implement a promise, because it's about 50 lines of code to actually get this concept. It's a little bit complicated, so this is probably the most technical part of my talk here. Bear with me for a moment at least. But the way I kind of look at this is our signal here is just a read function and a write function. I'm just using a closure here, and essentially you can see you update the value and you return the two functions. Of course, this doesn't do anything, so we need to do like a little bit more here. And the way we do that is we add this idea of subscribers, which is a set in this case. And essentially, now, whenever we read it, we go, is anyone listening? And I'll show how that works in a minute. And if they are, add them to our subscription list. And then later on, someone writes the value, and then you just go through all the subscribers and tell them it's changed. It's an event emitter, if you're familiar with those. And then the other side, which is our effect, we've got a global stack. It's called, I'm calling it context here, but it's just a stack that's globally available. So when we get the current observer, we're just saying like, what's on top of the stack? And then we kind of go through this cycle, essentially. Every time we run our effect, we clean up any previous dependencies, we push ourselves onto the stack so that signals that we read during that call stack, like while it's running, can see us. Then we execute the provided function, and then we pop ourselves off the stack. That's it. This is all the code here. I'm going to put it side by side for a minute, try and kind of run through our example in our head a little bit, but essentially, we create our friend, which returns our read and write functions. And then we go to run that effect for the first time. And essentially, the effect goes over into here, and it runs that execute function immediately, which pushes itself onto the stack, and then it runs the function. So it starts running that console log. It calls upper. Upper, in turn, calls our friend's name, and then when it calls the read internally there, it sees that that effect is on the stack. So then it goes, oh, okay, adds it to its subscribers. Then we just we run the rest of the function, log it out to the console, and it pops itself off. Sometime later, someone goes and updates the value, which at that point, the write function triggers, and in that list, we have our one effect. So we rerun our effect again, push ourselves back onto the stack, see the latest value, and do it all over again. That's basically it. That's all reactivity is. And from there, we can build a foundation for other primitives. A lot of them are not essential, but you can use as needed. Here's a few examples, for example, that I just grabbed from Solid. Create memo, which is for expensive computations. It's derived values. Create store, which is for nested reactivity, uses proxies. And then create resource, which is kind of a simple data primitive designed for suspense and concurrent rendering. It just takes a promise, returns kind of signal back. But at this point, what I'm describing actually isn't that different than a lot of solutions that might already exist out there. Vue, as I said, works this way. React with MobX works this way. But the next step is actually where things actually get interesting. And I'm going to do some live coding, I know. That's lots of fun, but it's kind of funny to me that whenever we teach reactivity, it's always like some console log, like hello. So I've got a counter here, and I want to do something a little bit more substantial. So I'm going to try coding live, and we'll just see how this goes. So wish me luck, but let's make an element. Let's make an H1, let's say. And I'm going to use vanilla JavaScript here because I think it'll be more descriptive. So I'm going to make an H1, and I'm going to append this to the document. In this environment, I don't actually have hot reloading really good because I'm like not using a framework. I'm just kind of add limiting it, and actually I'm going to turn off TypeScript because I'll probably do terrible stuff while I'm doing this. But essentially, my idea is we're just going to append our h1 to the page, and we're going to set the content of our h1. Like, there's no reason you have to use create effect to synchronize state. You can use it to, maybe tell the h1 that its text content should equal the string. And if all works well, here we go. We now have this working example. Now, the problem here is, obviously, this jumped straight to count equals 1. It happened too fast. You didn't actually see anything update. So let's add a button. And to save myself some time typing, I already have this prepared. So now I just added a vanilla JavaScript button. This is all pure vanilla JavaScript, and that basically our runtime we just showed a few minutes ago. So here we go. We have our h1. We have an effect that updates the text content, and then we create a button, add some text for it, and then I added like an inline click handler, which sets the count to count plus 1. So, and then we append both the h1 and the button to the screen, to the body, sorry. So this is just pure vanilla, and this should just work. Here we go. We have a working counter component. The thing is, this is fine, and this seems fun, but no one writes code like this. It's too much. Like, there's a reason we use frameworks. We don't all want to just go in and do vanilla JavaScript. So wouldn't it be cool if we could like have some syntax and stuff to help us? Well, maybe we already do. Like, there's this thing called JSX, right? So like, what if we could just, take our button and what was it, click me, and what we add a event handler to it on click, and where is our event handler? Here we go, and drop it in, and then we don't really need this anymore. We just assigned our button, which is just a DOM element here. Like, what if we could just compile JSX to what I just typed before? So then we still have a counter that works, right? Our button here is just a real DOM element. We don't have to necessarily have a VDOM. We just make it, it's a nice shorthand, right? And similarly here, for our h1 element, maybe we don't, want to do all this stuff manually. So what if we could just take an h1 and with a slight bit of compilation, essentially change it so that it's like this. And there's something a little fancy going on. Because we're calling a function, the compiler here, it goes, oh, I should wrap that in an effect. It could be dynamic. So that way we don't have to worry about writing create effect or anything. And suddenly, that kind of simple vanilla JavaScript, it's just compiling the JSX. We didn't compile the reactivity, we just compiled the JSX. And we still have a working counter component using JSX. And I can do a little better than this because, again, who writes code like this? So maybe we should make it like a counter component or something, and we can kind of pull in all this stuff and just bring it up here, maybe like this, and let's just, for now, as I figure this out, return our h1 and our button from our component. And do we have prettier in here? Yes, we do. Format document, much better. And then we can just call our counter function, because it's just a function, and spread it in. And sure enough, this should still work, right? I'm just making DOM elements now, they're in a function. There's nothing fancy about it. Basically, we click the click me, and just that one effect that updates that one text node here, that one number 6 here, is the only thing that runs. It's just our effect, right, that we had at the very beginning. So again, no one really writes code like this, so I feel like we can do better. We can probably get rid of these temporary variables. Like, we don't need the h1, and I can probably get rid of this button assignment here. And let's go to new line like this. And actually, no, honestly, why even use arrays? We probably could use something like a fragment, JSX fragment. And if I've done this right and I format stuff, again, to make it look nice, our counter should still be working good. And actually, this stuff at the bottom is kind of nasty. So I'm going to import a function here, maybe render from SolidJS web, which is kind of like React DOM, same idea. And then we can kind of just go like render counter document dot body or whatever. And now we can just get rid of this stuff. And Where are we? Yes, here we are. Loaded, and our counter still works. So this is starting to look kind of familiar. Like, I feel like I've seen something that looks like this before. Have you guys seen anything that looks like this before? Yeah? Okay. Well, this is where things get kind of weird, because if I console log in the middle here and go, counter, sure, we get our counter, and I hope you can see this, it's a little smaller. But if I click this button, well, wait a second, it's not console logging it again. And that's because this counter is just a function. You saw me write it. So it only runs once. We just have that one effect updating that one text node. So I can click this as many times as I want, and it's not going to rerun the component. Like, it's not even a component. It's actually just a function, if you think about it. So in a sense, I can do whatever I want here. Set interval. Let's do something that will blow up the world. Let's set interval at every second. And let's grab the click handler there too. Why not? Let's just use the same code and drop it in here. Sorry, actually I don't need the function thunk. Okay, sweet. So we have our thing counting up because it only ran once. And I can obviously click it. I don't know if you've ever tried this in React. You will crash your browser. But I just kind of throwing this out here because this is kind of cool. But it's obviously very, very different. I mean, it looks kind of similar, but it is very, very different. But what can we do with this? Because that's not really enough, right? So let's keep on going. Now let's put 2 counters on the page, okay? So I'm returning a fragment, and I have counter 1 and counter 2. And each of them, if you look at the bottom, hopefully you can see this. It might not be blowing up the best, but there's a 2 beside that counter. And because we made 2 of them, and I click it, and I click it, and the counter thing doesn't update anymore, and they have their own independent state, because again, we can just get states by wrapping them into closure. So that is essentially, state management, local state. It's a pretty easy pattern. But what if I want global state? Well, if you've been paying attention, it might occur to you that you could just do this. What if we just pull the state out, because now you have both components basically referencing the same object. And now we have global state, because it's all the same thing, and nothing is re-rendering. In fact, the only thing re-rendering are those 2 text nodes for each counter that we started at the beginning. So you see, we're not in Kansas anymore. I've got one more example for you on this line is prop drilling. That's a lot of fun, right? So let's instead of making it global, put it in our app component and pass it through. In this case, one count is just count, and the other is count times 2. And I'm going to make it so that one button is +1 and one +2. And if you look at our logs, we have app and then 2 beside the counter, so each component ran once. It doesn't really matter here, because even as I click it and go up by 1 or go up by 2, no console logs are rerunning. In fact, it doesn't matter how many components I have on the page. Nothing reruns. We're only updating those 2 text nodes. You can use context. Like, there's no performance consideration tied to components or context or any of that stuff. It just works. So this is super powerful stuff, at least from where I'm sitting. So I'm going to kind of pull this back around again. You might be going, okay, what's going on here? It's got to be a little bit more than you showed me before. And it's true. When we see something that looks like a function call or a member expression because of proxies, the compiler either wraps it in an effect, which we saw earlier with the DOM element. If it's a component, we just wrap it in a getter. So we just transform the props a little bit. And if you know anything about JavaScript getters, it just makes it lazy. So what we've done essentially is flatten the tree graph, because we just call these functions when you're in that final effect. The whole component tree vanishes to the point that you just literally have the one place in the DOM that updates. Okay, there's a trade-off here, and I got to talk about this a little bit, because if anyone's seen Solid, they're like, you use those weird control flow components, because there's a problem we have with map. I already showed you. We use real DOM nodes, and we do these fine-grained updates. The problem with map is if I'm mapping to real DOM nodes, anytime the data changes, I'd have to remake all the DOM nodes. It's terrible. So I do need to memoize it, and we could use a helper function, but I actually kind of made a choice. I was like, why don't we just use a component for it? And people are like, ugh, where's my just JavaScript? But I'm going to argue that this is super, super composable and actually aligns really well. What do I mean by that? Pretend now that you need a paginated component or a virtualized list or something. What do? in React? Well, you import it. And then, like, it's the same pattern again, right? Lists become paginated lists or virtualized lists. Conditionals become suspense or error boundaries. We have those components in React. So it's not unexpected to use components for control flow. That's basically it. And with that, we can actually return to that demo at the beginning here that I wanted to show, because I actually have that to-do app from React Comp. And it's almost like the original version of that example, right? We created some state, we created an event handler. This looks a little bit different, albeit, but then we have our for loop I showed you, we filter the list here, and we pass the props here. This is the final version that has all the interactivity on it. And at the bottom, I'm logging stuff. So yeah, if I hit a checkbox, it does update this count. If you can see, it's really small, but yeah, there it goes. It updates the count because I am updating that. If I change the filtered list, it does trigger the filter because nothing re-rendered on the items. It didn't bother triggering it. Obviously, if an item was hidden, then when I switch, it will also create one of those items again. Like, the work that needs to be done has to be done. But if I go to theme color, which you see, this is a prop theme color going through the component, because of what I've showed you already, it doesn't matter how many times I do this, no more console logs, because it's not updating anything that it doesn't need to. And this is super powerful because, like, what's not here? What are we missing? Where's the dependency arrays? Where's the use callback? Where's the use ref? Where is all those things? It was actually really hard for me to make this demo to show off that anything changed because so little changed. Like in the to-do, I had to kind of jump a console log in the middle of a JSX binding to actually show that something changed. So I just want to put it out here because, again, we changed the mindset a bit. We can do a lot of things. And that's what I call the reactive advantage, right? Components run once. No hook rules, no stale closures. Templates compile to real DOM nodes. So this is like a super low-level abstraction over the DOM. Like you have that escape hatch. You can always just go like, just grab it. And most importantly, state is independent of components. Component boundaries are for your sake, how you want to organize your code, not for performance. The performance is really good regardless. So, I mean, to summarize, I guess I'm just going to go with this, right? And as for that compiler from earlier, if you aren't careful, you no longer have the language to represent certain ideas. If your whole world, for example, is component, then how do you represent what lies outside of it? This is just illustrative, to be fair. There are solutions for this. And compilation is an important tool, but I want to point out that it's not necessarily a silver bullet. There are trade-offs with this. And to me, all of this, everything I've been talking about is part of a larger trend. I may have used Solid today to illustrate this, but this is just the beginning. Reactivity has already been serving as a common language between UI frameworks. Solid, Vue, and I mentioned recently Preact are using fine-grained reactivity in their frameworks. And if you squint really hard, to a certain degree, React and Svelte are too. They're not the same fine-grained reactivity, but they use the same language. So I'm saying, why don't we apply this beyond component boundaries? We've seen this used to great effect with Solid. Vue announced that they're actually working on a new compiler that generates code eerily similar to Solid. And I think this is just the beginning. There's other applications as well. We're talking bleeding edge here. I've been talking a lot about the cost of components for several years now, but recently we've seen it applied in amazing new ways. Components that need to rerun, like we've seen, means you need all the JavaScript in the browser even after server rendering. And this is known as hydration, if you've ever come across it, when a server rendered app starts up. We didn't have this problem in jQuery days. We invented this problem ourselves. Hydration is our fault. But if we can get rid of runtime components, we can also eliminate hydration. This has been realized, actually, by, I mentioned I work on Marco. The next version of Marco actually eliminates hydration, and another framework, Builder.io's Quick, also has figured out how to eliminate hydration. And this all comes down to going beyond components. I'm hoping very soon Solid joins that list as well. So it's not about VDOM or not, or about diffing or not. You could embed a whole VDOM inside a reactive system if you wanted. You could do concurrent rendering without a VDOM, and we do. It's about recognizing that our change model, while very much entwined with our UI representation, isn't the same thing. For this reason, the conversation around the world beyond components starts with reactivity, a system of change unto itself. Reactivity is already everywhere in JavaScript frameworks, from state management to compilation, but we can leverage it best if we fully embrace it and live in its declarative world. So maybe a revolution is not in the cards. Maybe just a reactive renaissance. But who knows what new worlds are only a step away. Thank you.